Be presenting his research on wood energy. Hey, Andre, thanks for coming. And then we'll have Elizabeth Hoffman presenting her research on aerosols on Granite Island. And I just want to double check that all of you are able to share your screens. So when it's your turn, you're able to present your research slides without problems. So I think that should, yeah, it shouldn't be a problem. I think it's all set up. Okay, wonderful. So without further ado, let's go ahead and give a round of applause to Mary. Thank you for coming, Mary. We're all excited to hear about your research on pancake ice. I've heard nothing but good things about your talk.
Okay, you can all hear me, right?
Yeah.
Okay.
Yep.
Okay, I think I'm sharing my screen. Okay, so I did my research on pancake ice. This was through the NMU Honors Program, the Lundin Fellowship. So I actually did a lot of my research before I even got the fellowship. I knew that I'm interested in cold climates, and the research fellowship is like, it kind of takes place in the summer. So I was like, I want to gather my data in the winter, and then I'll kind of review it and do my, find my findings in the summertime. So I just started going to Presque Isle a few times a week, and I would take photos and kind of learn more about pancake ice, all while I was applying for the fellowship. So first of all, ice is a very common indicator of climate change. I think a lot of us are pretty familiar with glaciers being used in that way. Often there's satellite images of glaciers, however many years ago compared to what they look like now, to show just the glacial recession as a result of the climate warming. So that's what I'm interested in. I just think glaciers are super interesting, but there aren't glaciers in Marquette. But there is ice in Marquette. There's lake ice. So I wanted to do hands-on research and be outside, gathering my data as much as possible. So I decided that I wanted to focus on lake ice. And it's not like this was a new thing. Like, a lot of research has been done about the relationship between lake ice and climate change. So I just included like a couple examples here of some, like the graph on the left is the freeze dates of a bunch of different lakes in the US, a lot of them centered around the US or the Midwest. Like for example, Lake Superior is the purple graph, and just showing over time since 1850 how the freeze date, the initial freeze date of like the winter season, has gotten later in the year over time, generally to the present year. And that is a trend for all of those lakes that are graphed there. You can see like initially Lake Superior would freeze, like it would start to freeze before January, before the new year. And then if you think now, because we're all in Marquette when the lake starts to freeze, and usually it's not even until like winter semester has started near the end of January. So that has definitely changed over time, and it's not just Lake Superior. And then on the right is a GIF. It's not working, but if I click on it, it takes you to the website that shows the last 48 hours of ice coverage in Lake Superior, and you can just see how much that changes over such like a short period of time, which is really different than glaciers. So like when we look at glaciers, we look at years. I guess it won't work, but when we look at glaciers, we see changes over long amounts of time, whereas like if you're looking at something like lake ice, it's very different to study because it changes much more frequently, like overnight or in like a few hours, just based on more like short-term weather patterns. So it's a bit different to study for my purposes as like a, I can't figure out how to go back to full screen. Okay. There we go. But it's just very different to study than glaciers, for example. So I learned a lot about that in my study. So why pancake ice? Because there's lots of different kinds of lake ice. I linked this whole Michigan Tech page where it lists like all these different names and definitions for different kinds of lake ice because there are so many. But just to show like how many there are, and it's crazy. And I was even like, well, this isn't pancake ice. What is it? And it was hard to tell which definition was correct because there's multiple terms for the same kind of ice and everything. And there's different sizes and everything. But pancake ice kind of appears to be the most common and the most easily like recognizable ice in Marquette and like along Lake Superior. I think a lot of us from living here have learned like what pancake ice looks like. And it just is the most frequent occurring ice from my research that I was able to find. So I focused in on that. It's just the rounded pieces of ice that often have those curved edges and the rounded or the raised edges from bumping into each other because they often appear like in groups and coves. For example, along the western edge of Presque Isle, which is where I did a lot of my research. Usually I would come to Presque, I would hike from like Sunset Point where the parking lot is all the way to Black Rocks, and I would take photos of like all the ice that I saw or ice that I didn't see. Like if there wasn't ice, I would still take photos along the shoreline. And sometimes there was ice that wasn't lake ice, it was ice that had like fallen in off of the coast of like, you know, where it's eroding. A lot of ice would form along there, like the shelf ice. So sometimes ice would break off of that and that would accumulate. So it was kind of like, now I have to distinguish the difference between the lake ice and then this ice that is kind of like calving off, kind of like when a glacier, like pieces fall off into the water. So that was something that I had to think about. And then I would compare the type of ice, the prevalence, the size, and I compared that to like weather data that I was able to get. But I really wanted wave data, but because in the winter they take the buoys out of the lakes, I wasn't able to get like what I was looking for, but it was definitely a learning process of like what I would want in the future if I conducted the same study, and also learning that for what I mean, I guess I was just trying to figure out what causes pancake ice, like what weather patterns, but because it's such like it doesn't just form and stay there, like it forms and like in several hours it can be gone, and it's changing all the time because there's so many factors that influence it that it was hard for me to gather that data. And then I would just need like a trail camera or like maybe like satellite imagery would be helpful. I know that right now I'm doing some work kind of similar to what I was doing last year where like I'm taking photos daily of ice. And I know that they have like more money and more things to work with than like I did when I conducted this study. So I'm definitely learning from that experience what would have been helpful when I was collecting this data. But I learned so much about pancake ice regardless. So yeah, I guess why pancake ice? Because I'm interested in ice, cold climates, the relationship between climate and ice and glaciers, snow. So I wanted to do that locally. And then I included this like satellite image of Lake Superior that I thought was really cool that just shows all the different kinds of ice that are in the lake at like a given time. Pancake ice is the orange. So if you look around Marquette, you can't even really see. There might be a little bit of orange, but there's a lot of red, which is the brash ice. And then white is unclassified. I just think it's crazy though that they're literally able to use a satellite in space to and like remote sensing to determine what kind of ice is present in Lake Superior. Like I think that's insane. And that's at like a much different level than the research that I was doing, but it just shows, I think with any research study, it just opens up the door to so many different paths. And I had a hard enough time narrowing down what I wanted to do in the first place. And then just learning all of these different things was just amazing, and it was so interesting. And I definitely want to continue my research with ice and hopefully go somewhere where there's ice like year round in the future to do more research like that. But yeah, and then I put some of the things I learned. I kind of already said this, but just that pancake ice and lake ice in general fluctuates very frequently. Currently, I mentioned it before, I am taking photos at like a roadside park along M26 currently. I go there like every weekday and take photos of the lake ice and like the shelf ice along the coast there for this study that is currently like, it's a National Science Foundation study and it's through MSU right now. And because the professor and the graduate student who are conducting the study can't drive up to Marquette every single day and see the site, I'm kind of doing what they can't do. And just going there, taking photos, sending them the photos every day so they can see the prevalence of the ice, but they're looking more at the effect of the ice on erosion of the coastline or the shoreline, as opposed to the relationship between that and the climate. And they have like a trail camera set up there. And then they're also doing like satellite imagery, bathymetric, like they're making like these computer models of the bathymetric, like of Lake Superior, you know? And so, yeah, I just think through that experience and kind of being part of a study that is like a little different, I'm learning a lot about things that I would have liked to incorporate when I did my pancake ice study. And I still go and see the pancake ice as often as possible. I think that photo, the bottom right, I took that this winter at Presque Isle by Black Rocks. But yeah, it just was a great experience, and like there's my research all put together. I think it was a pilot study. I just learned a lot of information and about the scientific research process, and it just made me want to learn more things. And it was kind of like, if I was to do this study again, what I would focus on more closely, definitely going to the site much more often. I didn't have a car last year, so that made it very challenging to go as much as I might have wanted to. Having a trail camera, and then being able to use more short-term weather data to find out what is actually causing the pancake ice to form. And then being able to compare that to my data from last winter and see if I was able to find anything, or compare, you know, when the first day that the ice was present to this season, and see how that was different. But yeah, that's most of it. If anyone has any questions, feel free to let me know.
All right, thank you so much, Mary, for that interesting study. I will kindly ask that everybody keep their questions until the end, just to make sure that all presenters have adequate time to present, and then we'll give the last bunch of time that we have to questions for everybody. But excellent job, Mary. I certainly learned a lot. I have a couple questions for you at the end.
Thank
All
you.
right, Andre, it's your turn.
Awesome. Thank you, Ryan. Yep. Okay. Everyone see my screen? So I'm Andre Brown, and my presentation is Power and Biomass, Creating Decision Tools for Socially Equitable Energy Siting Decisions. I'm working on this project with Dr. Sarah Middlefelt with the EEGS department, and assisted by the National Science Foundation. So one of the biggest talking points in the climate change discourse is renewable energy technologies and how important they are for slowing climate change. Typically, it seems like the technologies that get the most attention are really wind and solar and hydro. But the International Energy Agency actually projects that biomass will grow the fastest of all renewables globally between 2018 and 2023. So biomass is burning any recently living materials as opposed to fossil fuels for either energy or heat. This can be anything from the biofuels like ethanol that we're familiar with, but it also includes woody biomass. And this puts Michigan in a great place, making us an excellent candidate for biomass development because we have extensive forests. Half of our land area is covered by forests. And we also have a thriving wood products industry already, as well as a history of logging and forestry. So burning wood for energy is really like an age-old technology, but really in the energy crisis of the 70s and into the 80s, the technologies improved tremendously. This meant that now there's industrial scale biomass facilities that could really power a city. And so this meant that it really centralizes the power of these facilities, which is great because now we can produce energy for something the size of a city, but it does make it prone to the negative impacts associated with things like fossil fuel energy production. So getting into that, these industries, energy included, have a history of placing burdens disproportionately on poor and minority communities. So this includes pollution, noise that are localized around these facilities. And these facilities benefit the larger society, but sometimes it's to the detriment of specific communities. And many people really think of this as it applies to fossil fuels and toxic wastes, but it can manifest in biomass as well. This is because it does require burning material, which emits nitrogen oxides and particulate matter, which is harmful to human health, and sometimes lead. And then as well, the infrastructure required, like the trucks to bring in material, bring with it noise and fugitive dust. This can be really exacerbated when the feedstocks include things like construction and demolition waste, and some facilities actually in Michigan even burn tire waste. So that brings me to the objective of my research, what I'm looking at. With these implications in mind, it's important that decision makers have a lot of information for siting these facilities, especially in Michigan. So the objective of my research is to try and provide tools for decision makers to provide more holistic information. And I'll accomplish this using GIS-based land use suitability analysis. And this means taking in different types of criteria, like physical variables, such as the prevalence of, or the availability of feedstock. So this might be in forest cover or even proximity to mills and things, as well as proximity to infrastructure like roads and high voltage transmission lines. I think a case study that's really important to get a picture of why this is needed in Michigan is the case of the Genesee Power Station, which was built in Flint, Michigan in the 90s and became operational in the 90s as well. This was located in a predominantly Black community that already had intense industry concentrated there. And so because of these concerns, the community opposed the construction of the plant. And I've included these maps to kind of get an idea of the location around the plant. So on the left, it shows the demographics. It was built in a largely Black community. And it also shows the greater county who also benefit from the production of the energy, just as kind of a comparison. And then on the right is locations of the existing industries and environmental concerns, which as you can see is concentrated in that inner city area. So the outcomes of this, when the community went to oppose this, they faced many hurdles that other communities might not have faced. And actually the EPA conducted a study and found that the state of Michigan did discriminate against the Flint community. And they also signaled a need for more information regarding social variables. They wanted more holistic information during the planning process, which is kind of where my study comes in. So the first part of it is the land use suitability analysis to try and show where a biomass plant would fit in well. This is all preliminary results. I still have a lot of work left to do with my methodologies. But this map shows the kind of greenish blue shows the most suitable, and the brown shows the least, and it has to do with the forest cover of the area, the proximity to high voltage transmission lines, and proximity to major roads as well. And the second part is accounting for more social variables. So to do this, I'm going to use the Center for Disease Control's Social Vulnerability Index. It's at the census tract level and uses 15 different variables with socioeconomic themes, race, ethnicity themes, housing, transportation, to try and get a more holistic picture. And this was developed for to determine a community's ability to respond to natural disasters, and is actually being used in the implementation of COVID-19 vaccinations. But I would argue that it can also apply to communities' ability to resist unwanted development. The literature says that higher socioeconomic status means that the community has a greater capacity for resistance. So then this requires combining the two, and I'll be the first to admit that these are pretty loud, busy maps. So still some work left to do on that, but I've overlaid the social vulnerability index on top of my land suitability index. And this is to just provide decision makers with the ability to be sensitive to the community's needs. I don't think that a vulnerable community should be disqualified from
I'll shut mine down.
Oh, getting a little echo. Sorry. I don't think that a vulnerable community should be disqualified from development because it could bring with it economic benefits, but it is important to be to engage that community meaningfully and make sure that there are benefits to go along with the burdens. And then really, because it's so busy, it's, I think, helpful to zoom in at a larger scale and kind of hone in on some of the specifics. So on the left shows the Genesee County, and that star is the Genesee Power Station. And as you can see, that's in a really a cluster of highly socially vulnerable areas. And it doesn't show forest cover as well as I would like, but the Genesee County has much lower forest cover compared to the other biomass stations in Michigan. On the right is the Grayling Power Station, which is actually the same technology. It's pretty much the same plant in a different county, just for comparison. As you can see, the area that it's actually located in is higher or more suitable due to the forest cover. But it's also important to note that it's in another highly sensitive area. So maybe in the future, having more information could help result in more socially equitable outcomes. So these are some of the references that were included in the presentation. And then I also wanted to acknowledge Dr. Middlefelt for all her help and working together on this project, as well as the Michigan State RSGIS lab. They've helped me out with a few things, and it's been cool to see the larger project, as well as the National Science Foundation for the funding to make this happen. So yeah, thank you for your attention and your time.
Awesome. Thank you so much, Andre. That was a great presentation of how we can use decision support tools to ameliorate an environmental injustice. Good job. And next we'll have presenting Elizabeth Hoffman. I actually have an introduction from Elizabeth, the only one I was provided, but that's okay.
Good for you.
So if you'll just permit me, I'll read her introduction to properly introduce her and her research. Elizabeth graduated from Northern Michigan University in May 2020 with a Bachelor of Science degree in Earth Science. She's a member of Gamma Theta Epsilon and had 2 internships at NASA, one in the summer of 2019 and one virtually last summer in 2020. She loved every minute of it. She was a field technician during the summer at NASA Langley Research Center in Hampton, Virginia, and where she met a lot of amazing people. After the internship, she was able to go to Granite Island on a few occasions to do maintenance on the instruments there. But COVID prevented her from doing it this past year, but she was able to check in on this remotely during the summer of 2020. In 2019, she was able to present her NASA poster at the East Lakes AAG conference in October and had a wonderful experience there. The subject of her internship continued to interest her, and so she turned it into her senior capstone project here at Eags and eventually a research paper. She's still working with Dr. Susie Ziegler on possibly getting it published. Best of luck, Elizabeth.
Thank you.
She's not a native Michigander. She moved up here from Virginia to attend Northern Michigan University and has loved sending pictures of the snow back to friends and family back home. Her college career has been anything but traditional, but she graduated in the end and it was all worth it. I completely agree. And here's an introduction to her very interesting research on aerosols. The topic of her presentation today will be about the aerosol data that was collected at Granite Island during 2019 and what she found from the data. She'll talk about how clouds play a vital role in how aerosols affect climate by influencing changes to the Earth's radiation budget. There will be lots of visuals, and she hopes it will not bore anyone. I don't think that'll be a problem, Elizabeth.
Okay.
Since this presentation was based on the paper she wrote, there's not really a solid conclusion, only findings, but I sincerely hope the conclusion is that your paper is published at some point. That would be a great conclusion to your study. So without further ado, Elizabeth Hoffman.
Awesome. Thank you so much, Dr. Stock, for that introduction. Let's see. Let me go ahead and share the screen here. All right. Can everybody hear me?
Yes.
Okay. Excellent. Thank you so much. All right. Well, good afternoon, everybody. Hope you're all doing well and staying safe. My name is Elizabeth Hoffman, and today I'll be talking a little bit about aerosols recorded at Granite Island during 2019 and briefly on how aerosols relate to climate change. All right, so first off, Granite Island is a small rocky island about 12 miles off the coast of Marquette, Michigan. It is primarily known for its historical lighthouse and various projects supported by the island's owner, Scott Hoffman. In June 2018,
Elizabeth, I'm sorry to interrupt you. We cannot see your slides.
Oh no, I'm so sorry. All right, thank you for letting me know. Let's fix that real quick.
Sorry about that.
Oh no, you're good. All right, let me get my mouse set by this stuff. Susie to the rescue.
We practiced this so many times, and of course. So you did not see the slides at all?
No.
Do you see them now?
Okay, now we do.
Okay, there we go. We will
Thank
go.
you.
Let me go back to the beginning. There we go.
Do you see them now?
Yes.
Okay. All right. I am so sorry. All right. See, even if you intern at NASA, you don't have to be perfect. All right. Well, a little redundant, but little title card for my PowerPoint presentation there. All right, so I'll do this again real quick. Granite Island is about 12 miles off the coast of Marquette, Michigan. Just had a couple Google Earth images to kind of give people an idea of exactly where it's at. But the island is owned by Scott Hoffman, and we needed his permission in order to be able to go to the island and do the studies. All right.
Elizabeth, we don't see your slides changing, actually. It's stuck on
No?
slide 3. I'm so sorry.
No, that is okay. We are stuck on slide 3. let's see. All right.
Elizabeth,
Oh,
are you
yes.
also presenting on a screen in a room?
Oh, that might be it.
I think you just need to click mirror displays so that you're, so that you see the same things.
Try presenting it again, because you just, right, so
Okay. All right.
share screen. Did you do share screen?
Hang on just a moment. Share screen. PowerPoint presentation.
Yep.
Share. Okay. Let's
And then,
see.
I don't know if it's in the slideshow mode.
Mhm.
Hey, it works.
Okay.
It looks great. It's
So-
fantastic.
Okay, thank you. Thanks for bearing with me. All right, so if I were to step back one slide, does everybody see that?
Yes.
All right, third time's the charm. All right, I'll just give that one moment so people can see Granite Island. All right, and then on to the pretty visuals. All right, so. Okay, so back to this. In June 2018, SSAI employees associated with NASA, they worked with Scott Holman to establish a new surface validation site on the island. The site is known as Crave Granite Island, which stands for, stay with me, the Series Radiation and Validation Experiment, which is a component of an over-encompassing NASA project known as Series, or Clouds in the Earth's Radiant Energy System. NASA loves their acronyms. This site includes instruments which record solar irradiance, aerosols in the atmosphere, and general weather data. I know many of you will be happy to know that the site is self-sufficient and runs entirely on solar power. Oh, there we go. All right, so the equipment in place at Crave Granite Island consists of a suite of radiometric and meteorological instrumentation. The white chest you see here houses 18 batteries, which are used to store solar energy. These reserves come in handy during the long winters or days of prolonged overcast conditions. Okay, but for this talk, I'm going to focus on the instrument recording the aerosol data. The SML is called a sun photometer, or this instrument is called a SML sun photometer, and it measures microphysical and radiative properties as well as aerosol optical depths, or also known as AODs. It was this exact instrument that recorded the data I'll be sharing with you today. So just a couple images of the SML identical to the one on Granite Island. This one here is actually at NASA Langley. It was easier to get close-up pictures of this one in action. The SML is an instrument designed to track or look at the sun to measure how light interacts with aerosols as it passes through our atmosphere. As sunlight interacts with our atmosphere, it scatters, absorbs, or reflects the aerosols, and exactly how the sunlight interacts with them can tell us what type of aerosol it is. The SML can detect and interpret these sunlight interactions as aerosol optical depth. The data is then uploaded onto a website called AeroNet, the Aerosol Robotic Network, yet another acronym, and is available to the public. AeroNet is where I downloaded the aerosol data and used for my study. So just as a quick review, aerosols generally are tiny particles suspended in the atmosphere. The vast majority of them are naturally derived and only about 10% are anthropogenic. The common types of natural aerosols include ash from volcanoes, dust, pollen, sea salt, and smoke. Meanwhile, a couple common anthropogenic aerosols include sources such as emissions from burning fossil fuels for transportation or power plant use, and biomass burning from deforestation. Aerosols also play a role in facilitating cloud development by acting as cloud condensation nuclei, or CCNs. These tiny particles give water droplets in the atmosphere something to cling to and condense whenever saturation levels are right. So, aerosols and climate change have a strange relationship. Broadly speaking, aerosols can promote cloud development, which can cause an increase in cloud cover. More clouds mean less solar radiation can reach the Earth's atmosphere, which results in a cooling effect. However, not all aerosols have this effect. For example, darker aerosols will be more likely to absorb sunlight and warm up the atmosphere. whereas lighter aerosols are more likely to scatter sunlight, scatter sunlight and reflect it back into space. And there are some aerosols that are just harmful to our health. The types of aerosols may vary, and so do the clouds they form. So depending on the cloud type and what it's composed of, it will be better at absorbing, scattering, or reflecting the sunlight. And these influences on cloud development play a role in affecting fluctuations in the Earth's radiation budget. Aerosols and clouds play a huge role in how the Earth warms and cools, and there is still so much we don't yet understand. The internship I was a part of was actually focusing on this question, the series project. So long story short, clouds are one connection between aerosols and studying climate change. All right, so here is all the aerosol data for 2019. They plotted on a single graph. Some of it's a little incomplete, but majority of it's there. Each color represents a wavelength of visible light. And along the x-axis, you can see the date and time in UTC. So it's about 4 hours ahead of our time, Eastern Standard Time. Along the y-axis are the aerosol optical depth levels, or again, the AODs, and they are unitless. The smaller the AOD level, the cleaner the air. And as you can see, the air was overall pretty clean, but with a few exceptions. So the first thing to probably catch your guys' eye is a real big spike in the middle here, right? Usually AOD levels higher than 2.0 are considered dirty air. So the fact that I saw one that was nearly reaching 5.0 was kind of alarming. So I didn't know if maybe there was something wrong with the instrument. So I just wanted to find out what the reason was. So if I were to zoom in on the real big spike in July, it looks something kind of like this. You can see a total of 6 consecutive days before and after the big spike in July. But if I were to zoom in one more time, it would actually look like this. So here's that exact same spike in July, but for 1 day's worth of aerosol data. This had the highest levels of the year, again, nearly reaching 5.0. All right. And in contrast, here was actually the day that had the cleanest air of the year that I could find the lowest AOD levels. I looked at aerosol data for every single day in 2019, and January 4th just happened to be the winner. Sadly, not as exciting to look at as the July 7th day, but still pretty low. The AOD levels were like just about 0.045. All right. And here I have a couple of MODIS satellite images for those same 2 days, July 7th and January 4th. Let's see. The orangish hollow circle, let's see, by right here and right here, marks the location of Granite Island. And the little red patches up here are actually the forest fires up in Canada coming down from wind currents. The forest fires are about 700 kilometers away, right across Lake Superior, but you can just see the smoke like in the clouds there that made it the AOD level so high. Here was another image I wanted to share real quick. I apologize for the quality. It's a little bit blurry on this one. This was actually for another day with high AOD levels, May 31st. This was the second highest spike in the year. Here, these were wildfires, smoke from wildfires over 2,000 kilometers away being carried by air currents towards Granite Island. If I were to zoom on once more, there we go. You can see clearly that the cloud cover above Granite Island is in fact smoke, mixed in with regular clouds there. Okay, and finally, just 2 more neat satellite images I wanted to share. One image from April 4th and one from October 20th in 2019. I had picked these 2 days to represent 2 different aerosol conditions, and noticed when looking at the aerosol data, they had varied and steady conditions. April had AOD levels fluctuate up and down throughout the day, and October had AOD levels that were pretty stagnant. They were just straight across the board. I thought it'd be cool to show these images because the different seasons, you can see what the wind direction was that was much prominent in April, where all the ice buildup was. And you can see the color of the fall foliage in the October image. All right. So in summary, what I found during my study of aerosol concentrations at Granite Island was that there were only 2 days in 2019 that had aerosol levels high enough to be considered hazardous for your health. And they were both caused by wildfires. With a few exceptions, AOD levels shared at Granite Island in 2019 were on average less than 0.5, suggesting, relatively clean air, pretty clean air for the area. All right, and I'd like to take a moment to thank Dr. Susie Ziegler and Dr. Stock for their hard work and help in making this presentation go. And I'd like to thank my mentors, Brian Fabry, Fred Den, and Jay Madigan for their help collecting and analyzing the aerosol data. And a special thanks to Mr. Scott Holman for allowing these studies to take place on Granite Island. It's actually been really fun. Let's see, reference page. And thank you all for your attention, and sorry for the technical difficulties. Eventually got there.
Thank you so much, Elizabeth. That was an excellent
Thank you.
presentation. I love that picture, actually. It took me a minute to see on the other end of that solar panel.
It was a spur of the moment.